I see. We have
Ow! I'm Tim Loomis. I've already said hi to all of you guys in here. I work for NOAA as a contractor. My company is IMSG, IM Systems Group. They are the 5th company in the 16 years that I've been doing the Environmental Visualization Lab who actually sign my paychecks. Little companies go back and forth and up and down. Different contracts get signed, and for whatever reason, they just keep asking me to stay and keep doing what I do. The lab started, what's the next one? Do I have anything interesting? Sure, 1999, I started this thing. The director of NOAA at that point was Roger Baker, and he was livid that up until 1999, NASA would take geostationary satellite data and make pretty pictures and put them out there for the media to consume, and then put NASA on those pictures. That was a big deal. So NOAA and NESIS were trying to brand themselves with the data that they run, and they run the data off of the environmental satellites. So in 1997, I got out of the Navy, and 2 years later, I'm just sort of puttering around, and I answered an RFI that said, we need somebody who knows scientific visualization, multimedia, to establish some kind of practice here in NOAA for us to start to move NOAA's data with NOAA on it out to the media. So we answered the RFI. They gave nobody else put in a proposal. So they gave us some money and a month, and we took some computers out of the back room, got them hooked up, used a terrain modeling program on a black and white image, and extruded a z-axis with the grayscale of a hurricane, Hurricane George from 1998. It had just gone through. This was actually in November of 1998. There was a primitive camera in that software, so we set the camera up to go around this mush of a storm that we had made. We put some music on it and grabbed the National Weather Service's talking about this storm, put it on VHS tape, and presented it, and they were like, yes, that's exactly what we want. So they gave us a whole bunch of money and told us to get going. In 1999, in the summer, we got in Silicon Graphics Onyx 2, Infinite Reality 2 single rack delivered to us, because at that time, that was the computer that could take this data and turn it into pictures in less than 24 hours in order for us to snap some pictures and make them available. And, you know, in that time frame, 1998, we were 5 years from the HTML standard being written. Graphics, especially on the web, were nowhere. You could get a GIF. CompuServe had animated GIFs. That was like video on the early web. So we started the lab so that we could get this imagery out there. And our first images were 640 by 480 snaps from a couple of pieces of software, and were being put up on the web through CGI, through a Perl program. The Perl was actually writing the HTML and putting these images up on the web. So it was that was a big deal in 1999. And the first image that we put out, the first couple of images that we put out were for Hurricane Floyd that was coming up the East Coast at that time. The web server that we had grabbed somebody's desktop computer out of the back room, we put FreeBSD on there, Apache, and called it a web server, plugged it into the network and called it a web server. That server lasted on one of those days into the end of August when the storm was getting into North Carolina. That server crashed. It froze. So we were like, what's going on? We unplugged the thing, turned it off, physically turned it off, turned it back on, started the Apache daemon again, and within 30 seconds, it was down because it was getting hit so hard. So that server and the next 5 servers were victims of the media and the people out there in the world hitting those servers and knocking Apache offline. So up until that point, they weren't quite sure what to do with us, but they understood the reach after that. The first images that we put out we used a piece of software called Autometric Edge. It was a georeferenced geoid Earth that sat in 3D on this big computer that we had. Those guys left in 2002, left Autometric and went to Google and formed Google Earth. That's their work. The stuff that we were started on, the culmination of that was actually Google Earth. So our early pictures are 3D, nice extruded z-axis from the grayscale of those images. Very nice stuff. And we just got nailed, just continuously nailed. Around that time, we got called to run over to the wall and yank the plugs on our Onyx 2. And so I did. I got up, ran over there and pulled the plugs and said, I just fried my computer. Why did you do this? And they said, because you've been hacked. And the hacking actually happened from a student at Tokyo University who needed computing time on a big machine that had some power. And at that time, Silicon Graphics just delivered their computers open to the world, absolutely open. So that guy was searching for computing cycles, came on to our computer and went, let me FTP some stuff there. And they did. And so after that, TCP wrappers, that whole set of stuff started to come in, and they started to really lock down those networks.
And you guys started on those web services.
My funny story is that I got a call about, I don't know, 2 weeks later from a guy who was like speaking Japanese English, crying on the phone, saying, I'm sorry, and I couldn't really understand him. About a week after that, I get a letter on Tokyo University letterhead saying how sorry they were that this guy had hacked into our system, and that it would never happen again, and that he's being punished for whatever, right? So it's moved a lot since then, right? Where people own up to the hacking because they didn't know that it was hacking at that point, to now where nobody announces anything. But we've got 1,000 different ways to hack people. It's a huge paradigm change. Data flow. I could talk data flow. We talked about some of it earlier. There is so much more data. In terms of environmental data, there's so much more data coming in now than there was in 1999. There's a geostationary satellite, a couple of polar orbiting satellites, fairly low resolution, 1 kilometer. The infrared coming from the geostationary satellites were 4 kilometers per pixel. They're just taking sensing of a gigantic area with the charge coupled device and going, yep, this electrical charge equals this temperature, or this brightness value for the cloud tops. So data is crazy from now. I'm going to make some prognostications here because I'm an idiot, because idiots foretell the future. But this is going to tie into what I'm going to get into computing, places node, graphene economy. Anybody pay attention to graphene and what people are doing with that? Graphene is
Yeah, a little bit. Yeah.
is carbon in a two-dimensional lattice. At room temperature, it's a superconductor. Electricity and data flows right across it, no problem. Just passes it along without messing it up. If you can make a big enough sheet, you can make a construction material. If you have a construction material made of an electrical superconductor that you can dope to send signals in different directions, this also takes energy real well. From the sun, it just excites the electrons. That power will flow through it. So if you have graphene, you have that is broad and deep and fast. So right now, another one of my prognostications, as soon as the ability to build graphene into a construction material, as soon as that happens, Exxon, all of those people who take oil out of the ground, burn it, and throw the carbon into the atmosphere as a waste product, as soon as they have something to do with that waste product, it will no longer be a waste product, right? If we can take that carbon out and we can make a building material that will and move data through it, then what do you have? You have a complete paradigm shift in what they do with that gas coming out of the ground, because they're going to still sell that gas to people who make concrete, and they're going to say to the concrete people, you can have, you know, your base energy product, and you can make all the concrete that you want, but we want all that carbon back, because we're going to build materials with that carbon that are going to put you out of business. That shift is going to be really interesting when it happens. So moving to a graphene economy, every building, every road surface, if it has a thin layer of graphene on it, it's moving data, it's collecting power, and moving power to where it needs to be used. So at that point, to know at each one of those positions what the geographical elements of that generator are, and how that data is being sent out from that place, right? If you have a router that's built into the side of a building, for all intents and purposes, you still need to identify where that router is and give it some kind of base information that tells it where it is in the world and where it is within the network. Prognostication would be really interesting if it comes to fruition. A day in my life, I drink coffee. Check data flow. I have a link there. You guys don't care, but all of the data products that we put out, 70, close to 80, and we're doing some stuff with the new GFS model. If there are issues, any error checking, they come up on the website, on that website, so I can see what's going on at a glance, right? Linux, Tomcat is a Java servlet container. Whose Geo server is all written in Java, so it needs to be within a servlet container with the security that we can put around that, so people aren't hacking our Java all the time. There are environmental events going on around the world all the time. If there's a big storm that's going to hit the Philippines, I got to drop everything and focus on content creation. Going to the Japanese satellites and the polar orbiting satellites, grabbing data, grabbing pictures, putting it on the web for consumption by the needy, websites, all kinds of stuff. I get drawn out of my back-end stuff to do something for somebody in terms of an event happening now, past events. Atmospheric rivers are a big deal on the West Coast now. That can only be derived from an algorithm that hits the water vapor from satellites and gives you something called total precipitable water. Databases run MySQL and Postgres. MySQL is a backend for our basic website. Hopefully, I'll show that to you. JavaScript, of course, for the website, because we have to make calls. It used to be CGI. Now we use JavaScript to make calls to the database to serve people stuff. REST, all of our data is put into the database. We do to process the data that we get from the satellites in something other than, thank you very much, something other than just brightness values or true color, or red, green, and blue frequencies that get sensed by some of the satellites. Physlab Webmaster, questions from the media, project projection system exploded. It's always been an issue because when we started, SD was what everybody got, 640 by 4, 960 by 540 if we were lucky. That was a signal that the media could handle. But now it's HD. We run these things, are 4 projectors hitting a white ball, a 6-foot diameter white ball, that we project global images at 49 onto those balls around the world. In science centers and places like the National Zoo, they buy these systems and they install them, and then they go, what are we going to play on them? So we provide a lot of data and information and hand-holding for those things. 4K TVs, they made the TVs. There wasn't any 4K. Get calls from a gramophone here in Colombia. Do you guys got any? Can you make me a 4K of the storm, some storm? What exactly 4K? What do you want? Do you want UHD or do you want actual 4K? Well, I don't know. I'll call you back. So UHD is 3860 by 2048 rather than 4096 by 2048. The TVs are, so anyway, projection systems, documentation. I use Adobe After Effects and Photoshop and Illustrator every day. Maya for 3D stuff. People love 3D images, so I make them take the data and red because that's the warmer values are towards the Earth, the higher values, the cloud tops are farther up in the atmosphere. You can sort of pull that Z real easy with that. This is a piece of software that's been around for, geez, almost 50 years now, but it takes the Mercatus area format, which stationary satellites and most polar orbiting satellites around the world, everybody, the Europeans and the Japanese and the Chinese and the Indians, they start in as a because they know that there are lots of people that ingest with that format. But you can make also pretty pictures with that. RDL, OpenDAP, live access servers. You guys can check that out at some point. The assumptions. I need information about the place that I'm in. We're going back out on the web as a user. And the more information that people want to consume through their phones and their tablets and computers, they want to know this one latitude and longitude and altitude, right? But the information, I know we could get the tectonic plates, all that stuff. But for our lifetimes, right, that's not going to shift all that much. But the information is definitely going to move. There's going to be stores opening and people moving and concerts happening. All of those things are happening around around geographical spots. So this is back to, is Hadoop a good geospatial analysis tool? Is there a good geospatial analysis tool? I don't want to wait, of course not. Two-way street. A lot of data, a lot of social media, we're feeding back into the system, right? We're feeding the octopus out there. But a lot of, unless you enable location data and a couple of other things on your phone, your initial references videos, right? Technology stack for NOAA View. NOAA View is built on GeoServer and is brought to you on the web by OpenLayers. So these are image stacks that are provided to the viewer as zoomable, pannable, georeferenced images. I'll show you some of that. Linux, of course, Tomcat for the Java container. Postgres and PostGIS for geospatial databases, because Oracle owns Java. That's right. Oracle owns Java. Their policies for security are nicely packaged policies within your system. Then people don't hack us too much, right? We're always getting hacked, but it's a lot of just the basic tools that are automated by that. OpenLayers, jQuery, JCrop, CSS, Cesium, all of those are JavaScript libraries that allow us to code our site for different ways that people want to view the data. SSL certificates, we're getting into this, and you guys probably are teaching this now. Not a whole lot of sites. It's getting a lot better, but secure socket layer certificates are much more, are becoming environment that you serve your web page out through HTTPS, right? And you need the certificates in order to pass keys with people. So that's more of a bigger deal than it used to be. And I guess pretty soon, those certificates, you're going to want them on your phones, on everything, and Internet of Things. Those are sites that you can't read on there. So the Internet of Things. Right now, this monitor is a thing. It can be internet enabled, right? Does it have anything other than an address that can be found on the, and you can route stuff to this address, but is that useful in context? Meaning, here, but I want to know with my phone, because I have access, where exactly is that laptop or where is that monitor right now? It's for everything. Do we want our washers and dryers and all the appliances? The appliances in our houses seem to be the big push with Internet of Things, but it goes to it goes to clothes, and especially goes to clothes that are being shipped that have RFID tags on them. How can I locate that RFID tag and give it a geospatial component so I know exactly where everything is? So when things start to migrate in weird ways, I can have policies that will say, that will let me know that this geospatial, it's moving outside of its geospatial domain. So some questions, but what's the limit of that data gathering? And we can get into that for hours. Informed consent. Do I want my phone to tell people, one, where I am, but two, what the phone is being used for? The aggregate data collection is useless if people turn off those Internet of Things, off those communications. But but we're losing out on a whole lot if we do that. But so we move on. What does ownership mean at this point? If we have products that are sort of computing and talking across the network, do we still own them? And if we still own them, what do we have to say about what data they send out? So do we still want people to know what those systems are doing? Do we want them reporting on us or reporting on themselves? And if we want them only reporting on themselves and not us, then do we own the thing? And does somebody want that ownership to be, and the Internet of Things communication to be held by the human that owns the thing or the company that manufactured the thing? So that question becomes more relevant if I'm a business owner and my monitor, one of the monitors that I sold somebody is acting up. I sure would like to know that it's acting up so that maybe I can give it a firmware update or some kind of software change without it being on the back end. But if I also built into that, report back on the web transactions or some of those things, report that back to me too, then is that legitimate uses of the technology, or is that something that the human being, the human who bought the thing, wants to be, wants for themselves? And personally, I want that for myself. I don't want any machine reporting on me or my habits. I know lots of people that are like that. But it's interesting when you talk to people who manufacture this stuff, they don't see it that way at all. The Fitbits is reporting a whole lot on you, somebody else, to databases, right? Because that's all existing in the cloud. And there are a lot of people, a lot of statisticians who are sitting there going, oh, look at this great data. I'm going to be able to tell a lot about people from this data. To companies quite yet, because I don't want to just be advertised to. Because that's the paradigm, right? You collect people and then you advertise to them. I don't particularly be marketed to, because I'm marketed to 24 hours a day right now. Please stop. So do we all evolve to a rental model of stuff, right? If we see that and receiving data from its environment and from the cars that are around to implement. You know, if you want to know what's going on around you, well, maybe you own the car and I'll rent it to you for a couple of hours, right? You own the system and I rent time on the system. So that's another, maybe as an idiot, here I am prognosticating it again, but that reporting of what the things are doing, can you separate that from what the things? Okay, so back to GIS, no matter if the thing is reporting on itself, one of the things that it will need to report is where in the hell in the world am I at this given time? So that's that's one of those things. Just commerce information out of us through our devices to people who want to use it for whatever reason. Passwords, oops. I'm sure I'm preaching to the choir here. My password for Facebook is 20 characters long. It's a crazy thing. My 13-year-old who has a Gmail account has a 20-character password. She cannot start anything without going through daddy's password. Passwords can get ridiculous, and especially when everything that is in the Internet of Things, that's on the network, requires some kind of hashing, some kind of the requirement in order for data to go out, a pass back and forth saying, can I have the data? Yes, you can have the data. You're adding that much more complexity to the stream. So that was my thing with passwords. Interoperable standards, open source. You guys think open source is, for some of these things, for some of these broad areas, open source, or are we going to let Google and Tesla figure out the self-driving cars, and we'll just be like, oh, it's fine. A lot of great stuff with open source. I think you get to a point, right? You work with technology long enough, and you deal with the Esris of the world, and Google Unified Messaging Service for NOAA. We're going to get to a point. We use Google Docs for everything, for spreadsheets, for just text documents. Everybody has moved to that. The cost of that contract is going to go through the roof in about a year and a half. And then what the hell do we do? All of our stuff's on Google's freaking cloud. What do we do? So open source. Open Office is great, except this is owned by Oracle now, so whatever. It used to be great. Open Geospatial Consortium. You will probably, hopefully, be hitting their site, and NOAA does pay a couple of people, Jeff Delabardier, who you will run into because he does data management across NOAA. Loves OGC, he's on the board, and he attends their sessions all over the world all the time. Or do we let Google and Esri, NSA, NGA, CIA, FBI, do we let those guys tell us what to do, or what? Security. This is another little prognostication here. I'm saying that GIS will be the heart of the future of future internet security. That at some point, GIS will be built into every single device, and you will not be able to throw a hack from this device to that device without you being located here. Would love if that would happen. We'll see if that happens. Anybody worked with the Geospatial Transport Protocol? It doesn't exist. I just made that up. But there isn't that back-end protocol, right, to pass geospatial information. There are numbers for geospatial for locations. It really is who's using what sort of projection system. Are you doing decimal latitudes and longitudes, or are you doing whatever the like 100:08:34 longitude is some specific.
WTT?
I'm sorry?
WTT?
Oh, that's right. WGS 84 for geoid, for where on the model those particular latitudes and longitudes sit. WGS 84, that's right. That's where we're at right now. And then the identity at that point. And how many bits on does it actually take to identify me and my geospatial area, and are the networks fast enough to deal with that overhead? And they're definitely not right now. An opt-in. People who make GIS-enabled Internet of Things machines and services, whatever anybody uses, opt-in will be the default. There's no way that they're going to turn that off. And there, any time before people have the base knowledge of how to protect themselves from the devices that are reading everything to our search terms. HTML5, the Geolocation API is so easy to use, and it's such a tiny little bit of code, and you can stick that on any site and get a report back of who got to your site from what device and where were they. It really is. HTML5 is open to the world, of course. Geolocation, the Geolocation API is fantastic but there isn't any way to guard against that right now, unless you use Tor, one of those browsers that just obscure the heck out of the traffic on where you're going to go. Tor browser, that paradigm of let's send the signals all over the place, and not only that, but I made this algorithm and we're going to chop up your data flow and send it to 15 different places and then reaggregate them where you expected. They add a lot of data a lot of information on the data stream and manage to get it to all come together. So, you know, especially there are some technologies that have the ability to deal with lots of little pieces of information that have maybe not geospatial, but certainly other identifying characters on the beginning and the end of that data flow. Securing the router, security by proximity. How close? If you can tell that router to establish itself in a geospatial spot, is that helpful for tracking anything bad that happens that comes through the router? Broad distribution. I'm not sure actually where I was going with this stuff. Right. Is this? Are we going to plug all of the geospatial as it is in a I don't know, a decimal form or whatever onto each piece of information that we send around? And are we expecting the routers to deal with it, or do we go someplace else with the geo, more like a root server that they do for web addresses right now? So you can pass a small, like an 8-bit hash that will be recognized by a geospatial server, that if you want the geospatial information off of that piece of data, maybe the root server will serve that back out to you. The web mapping service. we do web mapping services. The NOAA View, one of the images on NOAA View breaks out to about 10,000 individual little images. It's really easy. Binary file on the end of a JPEG, right? Or a PNG. You can just stick it right after that closing thing, and now it's part of the file. If you put hacker tools on 10,000 images and had somebody on a site for whatever reason, zooming in and out and panning and doing whatever, you could be serving them hacking tools. The yin-yang, all kinds of different varieties of hacking tools. You just change them a little bit on each one of those, figure out which one gets in there. How cool is that? Because on the GeoServer side, there isn't any way to, because I set it up, right? I can serve out whatever the heck I want, however I want. And I'm going to put it on a PNG. I'm not going to crack into the header of a JPEG because they figured that one out.
Why would you want to do that?
To hack into systems?
No, with unless you were
A nasty person?
yeah.
There are lots of nasty people out there.
Yeah.
Our site gets nailed 15,000 times a day with people trying to get into the database, trying to break something in PHP, or in terms of government websites, just NOAA gets slammed every single day.
They all get slammed.
That's right. But if I'm just a nasty dude, and because with open layers I can break out any big image. You've seen some of the enormous images. You can put out multi-gigapixel images as on a tiled web server like GeoServer, and you zoom in and out. The paradigm is set up in open layers. Zoom in and out and pan all over the place, and what is fed back into your system are all of these little tiled images. They're stitched together, right? But your browser is still reading them and still
Like
translating them.
chips.
So I'm going to stick a little buffer overflow on the end of that thing. Can you imagine that? Somebody within a secured facility who goes, oh man, I'd love to see this massive image of the sunset. I'm zooming in and out and flying all over the place. Every single one of those tiles has some little payload on the bottom of it. How great is that? So in terms of security, there's that possibility. I don't know how much time I got like 10 minutes or whatever. The geographical markup language, these are like base like resource descriptions and markup languages. These are some things, if you guys get into GIS at all, it starts with these particular things. Geographical markup language. You can use GML to build your three-dimensional building or whatever within Google Earth. Just use GML and that structure to encode in your KML and make your KML available to the world, and you basically build any structure within the context of Google Earth. That's a geographical markup language. The back or forward. Oh God. The web ontology language that GRDF is an ontology. Geospatial resource description framework is being developed really well. That's another one of those open source. The World Wide Web Consortium is working on that very, very distinctly, because a lot of these things that I'm talking about and really can't happen. The Internet of Things can't happen until the interoperability standards are set, and there's some way for people to use them. Digital rights management. If I take that picture of the sunset and it's massive, and people come and visit it, I want to be able to say that it's mine. So the digital rights management for a geospatial construct, it could possibly be a big deal, because Merriweather Post wants to at a very fine grain level map out in 3 dimensions their beautiful whatever down there, right? And they want to be able at some point to film concerts that are going on. So maybe somebody pay $3 or $4 to see fish within a 3-dimensional construct on that computer. And where do I put all of that stuff? Because I'm a guy and we're all guys here. We're going to want to zoom in and check out the pretty girls that are up. That's the kind of stuff that's coming on. But I want to be able to control those rights, because I don't want somebody being able to say, ooh, look at this great concert that I got within this geospatial code base, and I'm going to hack it and sell it to somebody else, right? Same thing with music, except music got caught out because they didn't know it. They didn't know any better. The digital rights management came about because people were just stealing music. Extensible access control markup language. All of your service-oriented architectures are going to need some ability to do geospatial within the markup language in order for the ground truth of where in the world things are happening to be available for the systems that are going to eventually inform our phones about what's happening around us in the world. Big data. Geospatial is definitely the biggest of the big. We at NOAA sense a whole bunch of data now. You know, Darth Vader's Death Star, that thing's just a big hard drive. They took geospatial and the sensing of the world to the nth degree and just replicated it within a hard drive. The messaging overhead, we talked about some of that. Personal location data, the phones, and the Geolocation API in HTML5. They report back to the databases that are set up for them at Verizon and AT&T. So much more data about where the heck our phones are is going back to those companies than social media, than all the cat videos and the crapola that we type on within Twitter and some of those things. It's huge. And what are they doing with it? Getting ready to take over the world, of course. We need to analyze shape relationships on a massive scale. It is one thing to understand where somebody is or where something is, but for NOAA especially, when that big flare comes off the sun and it's going to come in and it's going to fry the infrastructure on the ground, we need to know on a massive scale what are all of the devices and all the interconnections that are going to be affected by that flare. And this is something that we are unprepared for. Because right now, tomorrow or this evening, they're launching a satellite that will sit at the Lagrange point, 1 million miles away from the Earth, at the stasis of the gravity field between the sun and the Earth. It will give us 15 minutes leeway to understand that enough of a coronal mass ejection is going to cause havoc to the electrical systems on the Earth. We will have 15 minutes at that time to shut all the electricity off in the entire United States if the Earth happens to be lined up for that. You can say that, we can say that, we can put it out over the airways, and maybe it will get to everybody who has the ability to shut off the main power generation spots. Maybe. But those relationships between all of those systems for a smaller thing that may happen, what's going to happen, here comes the next Hurricane Katrina. It's going to hit New Orleans, and it's going to cause what to happen? Where the outages are going to be? How is it going to affect people? How are they going to move? What are the relationships between all of these geospatially located things? And how can we predict how they're going to move? So, best big data platform for analyzing geospatial sensors and location data is, it isn't there yet. Hadoop is way, Spark, Postgres with the GIS plugins, really strong. But not for terabytes. Not for terabytes. And you need petabytes, zettabytes. This stuff is flying in so fast. How can we get any interesting statistical knowledge out of, and it's just not there yet. It may be, NSA's got some smart people. They build huge data centers, and they're certainly taking all the phone records and who's calling who and what, and they're modeling that somehow, but that's not getting out to you and me for probably 10 more years. I mean, those are very powerful tools. So there isn't anything that's out there right now. And it's built for it's built for the web. It's built for the way that simple messaging systems and the HTTP protocol and RCMP and TCP/IP, how are all of those protocols are shaped in specific ways, and you take it all in and you read it and you classify and quantify it through the protocols that are there, but there isn't really anything for geospatial at this point. So geospatial with time and altitude. So geospatial routers, you know, if you guys are looking for a job, go build yourself a geospatial router, because the basics are there. OGC is OpenLS. You could possibly, if you wanted to get into it, you can start building your own router and making your own protocol. And there's still plenty of possibilities for establishing a service that you can make money with. WebSockets. WebSockets is kind of cool. The specification is in HTML5, and it allows kind of like a tunneling through a TCP/IP connection to move geospatial data from database to database. This is something that is there in the specification. Nobody's letting people, you know, open up for WebSockets quite yet. But one of the things that maybe we can get to some geospatial data analysis on a grand scale. If people implement WebSockets, maybe we can have some level of access into databases where we don't have to pass keys and establish a relationship with the owner of the database in order to hit something specific, right? Like a location data for this thing. We can make that for this monitor. We can make it available because we've done our security check and the location of this monitor is not that big a deal, but because it's here, people can build relationships with other monitors in the general vicinity, and maybe you can come up with a service that you can sell. Oh, I can, you know, that monitor just blinked off. I'm going to go proactively and say, hey, your monitor just died. Can I replace it for you? Something like that. WebSockets is within the specification. It's not used a whole lot, but is one of those things that maybe will let us get into some free flow of geospatial data. Filtering. I said, oh yeah, filtering, because filter algorithms are, you make lots of money if you can write a decent filter algorithm for the fire hose of data that is coming in to any number of places. Filters and algorithms, if you take that job with NOAA, you're going to get into, you'll see just fire hose of data. Those ground systems that take the data in, they are just, the throughput is crazy. It's not Large Hadron Collider, you know, it's not CERN for crying out loud, but it's still on NOAA, who wants to make this stuff more or less open source. They want this data to be used and to be available. You got to be able to filter that. You have to be able to provide tools for people to filter that data quickly and accurately.
Anything else on what the data transfer rates?
I'm sorry?
Do you know what those data transfer rates are?
They're big.
Big.
Right. So the one thing with I mean, you're sending, the geostationary is sending a signal of GOES-R is going to send a terabyte every 30 seconds. It's just a very broadband radio frequency modulated blast to the receiving stations on the ground. The polar orbiting satellites hit Svalbard and someplace in the Pacific and someplace in France, a couple places in the United States. Wherever it flies over, you can buy the equipment that allow you the direct readout, because it will transmit. If you ask it, please transmit, it will go ahead and dump to your system. So that's gigabytes at a time, and you have that 3-minute window before it's over your horizon in order for it to dump to offload its data. It can happen, and it does, obviously, but that's not. How do we now aggregate all of that and get it into the models and get the models dispersed, processed and dispersed to everybody?
And to persist it to disks, because you can't really persist them that fast.
No, yeah, I don't know how they
Queues. Gotta be.
right. Various levels of, we're going to ingest here, right? 5 here to 8 here to 4 here to 1 here. Get the calibration in there. Geometry engines. What was I doing? Database. Right. Your database engine. How fast can you build the hardware, and how efficient is your database engine at getting into the data and pulling out what's being requested over and over again? Geometry engines, you know, the gaming engines right now are fantastic, but they exist within their own spatial world. They're not geospatially set up. There are a few that are, and certainly Google Earth. Google Earth is, I guess you could call that a geometry engine that they use, but it isn't. What they're doing is not really as difficult as it could be, because they're mainly, here's a structure. Let me shade it in a certain way that gives your eyes the ability to think that you're looking at a 3D object. It isn't immersive virtual reality, what everybody would like to do, right? They want us to have our glasses on and present us with what's going on around us in the world. And that's going to take geometry engines that can work over the web with a very, very small footprint, while hitting databases and constructing those 3D, 4D things in your eyes. NOAA would love to for you to be able to put on a pair of glasses and look up at a storm system and see the radar in 3D throughout that storm system, so that you know that you could possibly tell that within the clouds over here that I can't see, there's a thing twisting, and if I can hit play the forecast and it's coming towards me, maybe I step over here, right? NOAA would love people on the ground to be able to say, here's bad weather coming at you, do this, get out of the way by going this way, because our forecast for the next 15 minutes says that that tornado will be coming for this geographical spot. Space curve, large-scale analytics. I'm not going to get into that. You guys will eventually. Paradigm's still fluid, plenty of opportunities to make use of the research for commercial purposes. There's lots of open source, everything. Certainly databases, geometry engines, all of the frameworks for building the semantics of how you're going to talk geospatially within devices are out there. Get involved at department level, work through, you're in a place that you will be able to affect what happens into the future for NOAA. NOAA doesn't, Esri's going to come back and say, we're tacking 400% onto this contract. NOAA wants to be able to say, OGC is fine. We'll go at GeoServer, QGIS for analysis. We're going to roll our own. We're done with Esri.
Israel's going to come back and say all the spatial knowledge from us is in the country.
Well, so Esri's part of OGC. You know, they're part of this conversation. And there's no doubt that they provide interface tools that are wonderful, easily usable. Their back-end communications can certainly be standardized in ways that other people can use, that other people can get some value from them. I wasn't sure who I was going to actually have in this class, so don't let your devices define you on the web. If the next one, don't be a Luddite, keep up with the tech. Don't let your old piece of tech that you really love because you have, vintage Angry Birds on it, don't let that stop you from continuing to update your technology because it's moving fast right now. Do you have a question?
Yeah, I know. I missed like the whole entire briefing, but I just had a question. So like how would you, as far as that, because I know that like in my previous job, we've had, we had, stuff, that was, that was kind of like the latest and greatest, version of whatever. But the thing is that a lot of the stuff, because of, various things, it had a bug in it, it was like a known thing or whatever, you have to also keep that in mind as well, right?
Right.
Because you want to make sure that the new version or the new technology that you're incorporating into your system will indeed work with your system, in a full sense.
Software or hardware?
I'm more just speaking of software.
Definitely.
Yeah.
Yep. Especially with software, you got to know who you're dealing with.
Right.
Right. Hardware is easy to baseline. Software, you can't really baseline. You're hoping that that they've done their due diligence themselves. NOAA always stays a couple of steps back from the latest and greatest.
Oh, okay.
And so I guess what I'm getting at with this is, personally, don't just get stuck with your old phone, because if there's a way to make that phone communicate outside of itself, or communicate about what's happening, what the person using it is doing with the phone, that's the kind of stuff that I would like you not to be able to get caught up in.
Right.
Earlier, I kind of railed against our devices reporting what we do much more than reporting what they do, what the device does.
So also speaking to that, there are some people, that I work with, and they admitted in our new employee orientation that they don't want to get a smartphone at all. I'm sorry.
Yeah.
Yeah, they don't want to get a smartphone because they don't want to be susceptible to malware and all those other things that come through. So so what would you say to them? In terms of
Learn a little bit about how to lock your device down. Right.
Don't be afraid of technology.
mm-hmm.
So technology is not the devil here. It really is the ways that companies are extracting data from that technology that I think is the worst thing. Because if you just get your phone, if I can craft a website that will grab information from you, you have to visit the site first. But there's a lot that I can learn about you just by checking to see what I can ask your phone to provide for me. And if you haven't locked it down, and for the most part, phones, when you buy a phone, especially in commercial individuals, when we buy a phone, they're open to the world, right?
Mm-hmm.
You got to physically go into the settings in an iPhone and stop location services and shut those reporting things down.
Mm-hmm.
Because Apple's fine. I drank the Kool-Aid a long time ago. They can have all the information that they want from me if it will make their devices better, if they will make my experience better. But I'm not buying an Android phone and loading an app on it from Joe Bob's apps
Mhm.
because I don't know what he's asking of my phone to report against.
Hmm.
And especially with apps, especially with Android, that operating system is wide open, and it's meant to be wide open. If you're not locking it down yourself, then it's meant to be wide open because Google needs all of your information about you to be reported back because they provide advertisement. I'm still convinced that Apple wants to make me a better device rather than sell me some bull, right?
Mhm.
So that's those. There are two paradigms there, and one of the reasons that Apple, I think, is the most valuable company on earth is because they're collecting data to make better devices. They're not stuck with an advertising revenue stream as the thing that keeps them going.
Mm.
So
Interesting.
we all of us buy new phones because we own a lot of Apple stuff.
Yeah.
And so far, you know something, we use some budgeting apps that exist mainly out there
Mhm.
on the Apple cloud. They've been secure. Apple vets the heck out of their apps. They don't get on the store unless they've already been through and they've got their own coding schemes, I mean, Apple's a great paradigm. And then there's everybody else right now. Open source is definitely that way.
Right.
All of these things that we were talking about earlier, I can use all the open source tools that I've talked about for nefarious things because they're open. You know, you take that, you package those open source tools in such a way that it makes value for somebody that you can sell it to. And you can lock it all down. You certainly can. All of this is GeoServer. You can lock GeoServer to the nth degree so that you're only providing these specific tables or information from these specific tables, but you have all the rest of this stuff around it. You don't need to flow in the other way unless you do. I mean, if you have a site that is geospatially enabled that you want to sell advertising to, you know. So anyway, I don't know if I have anything else. Do you guys want to see a website or do you need to get out of here? It's up to you. I can see if I can figure